This screencast is for this example in this document. After t seconds, a ball tossed in the air from ground level reaches a height of h feet given by the equation h is equal to 144t minus 16t squared. So the first thing we need to do is put that into our y equals 144t minus 16t squared, and instead of t I'm using x because that's what we used in the calculator. And then this 144, that means that is the initial upward velocity of the ball, and it is at ground level. So that's why we do not have a starting point over here in our y equals. So the question is, what is the height of the ball after 3 seconds? We can go ahead and find this answer two ways. The first way is we can use the table and check out 3 right here, because remember x is seconds and y is the height above the ground. So at 3 seconds it's 288 feet. Or we can use the equation. We had 144 times 3 minus 16 times 3 squared, which is 9, but I'll use the equation just like that. And we come up with 288. The next question is, what is the maximum height that the ball will reach? So we're going to use the table in the calculator and try and see if the numbers mirror each other. So right here at 0 seconds, the ball is 0 feet off the ground, and then at 9 seconds it's 0 feet off the ground. And then for 8 and 1, they are the same. For 7 and 2, they are the same. So since the numbers mirror each other, that means that we should be able to nicely use the table to find the maximum. It should be somewhere in between 4 and 5, because 4 and 5 are both 320. So we do second table set. We start at 4 and we count by 0.1, and I'm thinking it should be right at 4.5. And there we have it. 4.5, we get 324 feet. It is the only one that occurs because at 4.4 and 4.6, the numbers are exactly the same. And then the same at 4.3 and 4.7. So at 4.5 seconds, the ball reaches a height of 324 feet. We just answered this question in the table, but we can also answer this question using the graph by looking at the table, okay? So we know that somewhere in between 0 and 9 seconds, the ball is going to be above the ground. So our x's, when we set up our window, should go from 0 to 9. And then our y's, when we look at the table, the maximum is somewhere right around 320. That's not the nicest number, so maybe we make our y's go from 0 all the way up to, say, 350. A y min of 0, and then go all the way up to 350. And sure, counting by 5s, or let's count by 15. So it's a number that's a little bit nicer. And then we push the graph, and we have a nice trajectory of our ball. And then to find the maximum, we do second calculate, and we're finding the maximum. So we push the number 4, and the left bound is to the left of the maximum. So right there seems to be a good point. Push enter. And then it asks for the right bound, so we go over to the right a little ways. Right there, perfect. Push enter, and now it wants us to guess a value. So we push yes, and it does some calculating. In about 4.5 seconds, the ball is 324 feet high. Perfect. The next question is, find the number of seconds it will take for the ball to reach 224 feet. Now, this is very similar to when is the ball going to hit the ground, because 224 feet, when looking at the graph, it's going to pass 224 on the way up, and it's going to pass 224 on the way down. So we need to use the table for this. And 224 is at 2 seconds, and 224 is at 7 seconds. And the last question is, after how many seconds will the ball hit the ground before rebounding? And again, we're going to use our table for that, and we're looking for when y is equal to 0. So this, it starts at 0, but we're not interested in that. It says after how many seconds, so time has elapsed, and that's right here at 9 seconds. Now, I could also use my graph to determine that answer. I'm going to fix my window a little bit so that my x's go beyond the parabola, and then I'm also going to fix my y's so that I can see below the x-axis. So now when I push graph, I can see that, and that's not even really far enough below. Let me fix it a little bit more. We'll make this number -30, and then that'll definitely give us enough. There we go. And now we can see that on this side, there is a part of the graph that is to the left of the 0, and then there is a part of the graph that is to the right of the 0. So if we are going to find the zeros here, that's option number 2. And the left bound should be on the left side of the 0. So our y value should be a positive number. So I'm going to just move my blinking spider a little bit closer here. Okay, so I am positive y value because I'm to the left of the 0. Push enter. And then my right bound, since I'm on the right part of the parabola, the right 0, okay, it should be negative, my y value. So I push enter, and then I want it to take a guess, and it tells me that right at 9 seconds is when the ball is going to hit the ground. Okay, so that pretty much finishes out this example. Let me know if you have any questions.